Hi everyone, it's almost noon. Good afternoon to all of us. We have a rather interesting problem. Let's read this problem. A 250-gram yo-yo moves downward, releasing itself from its string. If this yo-yo can be considered a solid wheel, and is positioned correctly as shown in the picture, how much torque is acting on the yo-yo? To make it more visually clear, we will create an animation of this problem. Notice that the yo-yo is not only moving vertically downward. The yo-yo is also rotating about its own axis. What does that mean? It means the yo-yo is rolling vertically downward. To analyze this system, we will place the yo-yo in a two-dimensional Cartesian coordinate system. We set the horizontal axis to be the x-axis, and the vertical axis to be the y-axis, where the center of the coordinate system is at the center of rotation. In general, the direction of motion is the positive axis. Thus, the positive y-axis is downward. This is indeed unusual at first. We are free to choose a reference. Choosing the right reference will make the analysis easier. That's all. Next, we will analyze some of the forces acting on the yo-yo. This yo-yo is located on the surface of the Earth. The yo-yo will experience the Earth's gravitational force, mg. Because the gravitational force acts at the object's center of mass, this force does not cause the yo-yo to rotate. The string does not break, the string exerts a tension force on the yo-yo. This force has a moment arm of r. This means that only the tension in the string can cause the yo-yo to rotate. Now, we will analyze this process mathematically. Starting with translational motion. The yo-yo moves only vertically downward. There are two forces acting on this axis. mg minus t equals may. Remember, the downward direction is positive. Since the yo-yo has no acceleration along the x-axis, the magnitude of the yo-yo's acceleration is simply the acceleration ay. A is equal to ay. We can replace ay with a. mg minus t equals ma. Let's call this equation equation 1. Next, we will analyze rotational motion. Sigma tau is equal to I alpha. As mentioned earlier, the only force with a moment arm is the string tension. Tr is equal to I alpha. The yo-yo can be thought of as a solid cylinder. The moment of inertia of a solid cylinder is half mr squared. An object rolling without slipping will satisfy the equation, A equals r alpha. This equation can be simplified to T equals half ma. Let's call this equation 2. We have two equations, from which we can calculate the translational acceleration of the yo-yo. Simply substitute the value of t from equation 2 into equation 1. All factors contain the quantity m. We can cancel that value. We can write this equation as A equals 2/3 g. Now, the torque acting on the object is the tension in the string times the radius of the yo-yo. This is equal to 1/3 mgr. Of course, this value of A can be substituted into equation 2 to get the value of t. T equals 1/3 mg. Now, we can calculate the magnitude of the torque. If we read the problem again, we will find that m is 0.25 kilograms, the radius of the yo-yo is 0.27 meters, and the acceleration due to gravity is 10 meters per second squared. Now, we can calculate the magnitude of the torque. It is equal to 1/3 of mgr. All these values are readily available. A little scribble on a piece of paper reveals that it's equal to 0.225 Newton meters. This is the torque acting on the yo-yo. Hope this helps. And don't forget to watch the next video.